Welcome to Pre-Cal Lecture 4.5a, where we're going to talk about an introduction to logarithmic functions. You're on page 2 of your note packet that covers section 4.4 through 4.6. We're kind of up here near the top. And let's start going through the notes. So 4.5.1 is an introduction to logarithmic functions. So those bullets, logarithms and exponential functions are inverses. So you need to keep this in mind. A log is an exponent. So y is equal to log base b of x is equivalent to b, the base, to the y powers equal to x. So let me write that down to emphasize that. So a log is an exponent. What that means is that the answer to a logarithmic expression, the thing that's on one side of the equals sign by itself, that's always an exponent. So if we have y equals log to, and I'm going to use some different markers here, log to the base b of x. So log to the base b of x is equivalent to, let's see here, that's the same thing as b, the base, to the y power. Okay, y power, b the base, b to the y is equal to x. So I kind of think of it as a visual pattern. B to the y is equal to x. All right? So let's do some examples here. Let's say we want to evaluate log, in fact, let me write that down so you know we're evaluating log to the base 2 of 8 is equal to, and I use a question mark instead of an x. So this is the exponent. Okay, we're solving for what is the exponent. So the way that you rewrite this as an exponential equation, what you're used to, which is this right here, is 2, the base, to the question mark, the exponent, is equal to 8. So when we say a log is an exponent, that is the exponent. Instead of having it raised to a base, we write it out this way. And there's a lot of, I'm teaching you now what it is, but it can be really, really useful in math. So what is question mark? Question mark is going to be equal to 3, right? So 2 to the third power is equal to 8. So all of these will be evaluate log base 2. We're just going down the page of your notes. Log base 2, 2 is the base, of 1/4, that's the way you say it, is equal to question mark. So what this is saying is, what power do I raise 2 2 to get 1/4. Okay, that's what this is asking. So 2 to the question mark is equal to 1/4. So what power do I raise 2 to get 1/4? Well, that's going to be -2. 2 to the -2 is equal to 1/4. So that's the same as 1 over 2 squared, which is 1/4, right? 2 to the -2 is 1 over 2 squared. Remember, you take, if it's to a negative exponent, you send it to the denominator. All right, let's evaluate log to the base 2 of -3 equals question mark. So 2, what that's saying is 2, the base, to what power the exponent is equal to -3. Well, you can't, question mark does not exist. There is no exponent that you can raise 2 to get a negative number. That would always be positive. So you can never take the log of a negative number. You can try it, and in your calculator you get an error. All right, let's do one more of these. We're at the bottom of page 2 on your notes. We're going to evaluate log to the base 27 of 3. All right, what is that equal to? Well, that's saying 27. So we're finding what exponent do I need to raise 27 to get 3. 27 to the question mark is equal to 3. Well, if I take the cube root of 27, I get 3. So question mark is going to be, in fractional terms, it's like taking it to the 1/3 power, right? That's taking the cube root of something. All right, we'll turn over to page 3 of this note packet. We are in 4.5.2, and we're going to be converting between exponential and logarithmic expressions. All right, you don't have to write this down because that is already titled. So a log is an exponent. Go ahead and highlight that again. And also, we've got this up here written again. It's so important, I'm going to rewrite it. Y is equal to log base b to the x is the same as b to the y power equals x. The variable that's by itself is the exponent. That's what a log is an exponent means. Okay, so we're going to rewrite as a log two to the 5th equals 32. All right, remember that 5 is the answer, so it's going to be by itself on the equal sign. 2 is the base, so log to the base 2 of 32 is equal to 5. 2 is the base, so there's the base 2. The answer is 5, so it's by itself, and of 32. All right. let's see if I can squeeze in another one where this is the same instructions. We're just going to rewrite 2/3 to the negative 2 power is equal to 9/4. Okay, negative 2 is the answer. Okay, negative 2 is by itself on the equal sign. And you know you're going to have log in here. The base, which is what you attach the exponent to, is 2/3. So log base 2/3 of 9/4 is equal to negative 2. All right, let's keep going. Let me erase real quick here. Okay, we're still rewriting in about the middle of page 3. Rewrite log base 6 of 6 equals, so we're rewriting as an exponential this time. So log base 6 of 6 is equal to 1. Well, the base is 6. The exponent is the one that's by itself over here, so 6 to the first power is equal to 6. All right, next we got 2 more to rewrite. And we've got log to the base root 3 of 9 equals 4. So this time we're rewriting as an exponential statement because it's a log statement. Well, the base is the square root of 3. The exponent is the one that's all by itself. So to the 4th power is equal to 9. And you can check, is this true? Square root of 3 times the square root of 3 is 3. Times the square root of 3 times the square root of 3, another 3. 3 times 3 is 9. So that works. Okay, let's rewrite log to the base p of q is equal to r. So I actually just do it by pattern. P to the r equals q. Base to the exponent equals what you're taking the log of. So P to the R equals Q. All right? So after you do a few, you'll get used to the pattern. The homework is worksheet 4.5a. Let me glance at that and see. So that it's 12 problems of doing just what we've been doing. So I don't really see any that I'm just going to give you any hints for. So give it a go, and we'll talk about it on the solutions video.